Good afternoon, everyone. So today I'll be going through exercise 8.1 from the new Discovering Math textbook. Okay, so this is slightly this textbook is different from the Think textbook lah. So users of this new Discovering Math textbook can use this video. Okay, so let's first go through question 7. So the diagram shows the relative position of three hotels A, B, and C. So the bearing of B from A is 162. So B from A 162. So, okay, I know there's a lot of fraying lines here, but just bear with it. So, bearings of B from A is 162. So, you draw a compass. Okay, the compass is already given at A. So, B from A is 162, right? So, this is 162. This angle here is 162. All right? Okay, and then given that AB is equals to 6 km, all right? And then, which is labeled lah, right? And CA is equals to 4K and find angle BAC. So angle BAC is this angle shaded over here. All right, so with this, I'm going to use a cosine rule. So for 7A, angle BAC, right? So I'm going to use cosine rule. Let me shift this over. Okay, so that means we will have 5 square equals to 4 square plus 6 square. All right, B square plus C square minus 2 times 4 times 6, right? And then cosine angle BAC. Okay, so when we calculate this, we have cosine angle BAC, right, equals to 5 square minus 4 square minus 6 square over negative 2 times 4 times 6. So angle BAC is equals to cosine inverse this fraction, which is 9 over 16, right? We will have 55.77113, and then we round off to 55.8 degrees. Okay, so this is angle BAC, right? 1 dp. Okay, so this is for part A. So for part B, you're going to do it in black. So part B, the bearing of C from A, okay, of C from A. So they want this angle over here, right? Bearing of C from A. So yeah, we can just take 162. Oh, let me take a look. We might have to take, let's see. Yeah. Just give me a while. So 162. We have to take, wait, they want the black part, which is like, okay, so it's until here. So the whole thing is 162. So we have to take 162. Hold on, bearing of C from A. We have to take 162. Yeah, so it's actually just 162 degrees minus 55.8, 77113. Okay, so this will give me a result of 106, right? 106.228. 2288 lah, which is 106.3 degrees. Okay, so this no, 106.2 degrees actually. Yeah, my cat. 106.2 degrees. Right. Okay, 106.2 degrees. Okay, so this is for part B. Okay, let's take a look at question 7C together. So yes, they want us to find the bearing of B from C, right? So this is the bearing that we want, right? This is the angle that we want. All right, so basically, and then we also found out in part B that this angle over here, right, the bearing of C from A, right, this is actually 106.2288. Okay, so we got to find out this angle over here. Okay, this angle. So it's an interior angle kind of thing. So 180 minus 106.2288. All right. And this will give us, oh no, give me a moment. This will give us 73.7712. All right, this is 73. This part here, 73.7712. All right, then now we got to find out what is our angle ACB. So angle ACB, we can use sine rule, right? So sine angle ACB over 6 equals to sine angle BAC, right? Angle BAC over 5. All right, so if you were to do cross multiplication and everything, so sine angle ACB is equals to sine 55.7711 over 5 times 6. So angle ACB is actually equals to 82.819. All right. Okay, so this part here, ACB is 82.819. Right. So what do we have to do? Just minus law, right? So 360 minus 73.7712 minus 82.819. Okay, so 360 minus 73.7712 minus 82.819. Okay, and that will give us 203.4098. So round off 1 dp, 203.4 degrees. So the bearings, right? Just end off your conclusion. So the bearing of B from C is equals to 203.4 degrees. All right. Okay, so this is it for question 7. Okay, let's go through question 8 together. So the diagram shows 3 buildings, A, B, and C on level ground. The bearing of C from A is 145. So let's annotate lah. Okay, so bearing of C from A is 105. So this is 105, 145, sorry, 145 degrees. And then angle ABC is 36 is written here, all right? And then angle ACB is 50 degrees, which is written here as well. So they ask us to find the bearing of B from C. So we have to draw a compass here, north. So try to make sure it's parallel lah, right? And then the bearing of B from C is like that. Turn one round over here. Okay. Yeah. So what do we do? Okay. First thing first, we have to find this angle here over here. Okay. How? Using interior angle. So focus here, here, and this, and this. So you have something like that. Okay. So this is 145, and then this is the angle that we want to find here. All right. So how come we can do this interior angle? Because all of this is north facing, so they are parallel. All right. So the first step, okay. So the first step, part A. So first step is we take 180 degrees minus 145 degrees, which give us 35 degrees. So this angle here is 35 degrees. All right. And then after that, we can find bearing of B from C already. How? Just take 360, right? Minus 35 minus 50 lor. Okay, can? So this will give us 275 degrees. All right, so the bearing of B from C is 275. So this is for part A. All right, so let's move on to part B. So find the bearing of A from B. So A from B, right? So from B, so means we have to draw same thing, a compass at B. All right, so they want this angle over here. This is the bearing of A from B. All right, so first thing first, we need to find out what is our angle BAC over here. Okay, angle BAC. All right, and then after that, we make use of alternate angle. So look at this, 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 and this. So that means we got to find out what is this. All right, we can find this. Why? Because this is 145. So this angle over here is 180 minus 145. So first step, 180. Oh, which we already have it actually, initially. Anyway, just write it. So 180 minus 145 degrees. So equals to 35 degrees. Okay, then this angle over here, all right, we have to find angle BAC first. So angle BAC equals to 180 degrees minus 36 degrees minus 50 degrees, which will give us 94 degrees. All right, so this is like sum of angles in a triangle. All right, so this is for angle BAC. So in order to find out what is the remaining angle here, we take 94 degrees minus 35 degrees. All right, okay, my cat is over here again. Okay, and this will give us 59 degrees. Okay, so as just now we discussed, right, this is north, this is north. So alternate angle, this, right? So that means the bearings, right? So I write a statement lah. So the bearings of, no, dumb. This is my cat. Okay, so anyway, so the bearings of A Sorry, okay. The bearings of A from B is equals to 0, 5, 9 degrees. All right, so that is for part B. Okay, let's move on to part C. Part C on the right. Okay, so the shortest distance of A to BC, right, is 950. So let me just erase all this first lah. Or then later we fill in the blanks for the angle that we have found in part A and B. So shorter distance from A to BC is 950. So let's imagine there's a shortest distance here. And the shortest distance means it will form a 90 degree with BC. Okay, this is what we mean by shortest distance. All right, so find the distance between B and C. So they are saying that this is 950, all right? And then they want us to find BC. Okay, so what do we do? So first thing first, give me a minute. So first thing first, we got to find, okay, I'm just going to label this as X. It's covering me again. Okay, we're going to find, well, oh no. Okay, we're going to label this as X. Okay, so we want to find what is BX. Okay, then after that, we want to find what is XC. All right, then we BX plus XC, then is BC. Okay, so first thing first, Tuakaso. So I want you to focus on triangle ABX. All right, then we are going to use Tuakaso. So that means in this case is tangent, right? 36 degrees equals to opposite, which is AX over BX. Opposite over adjacent, so BX, right? Which is equals to 950 over BX. All right, so BX will be equals to 950, right? Divide by tangent 36 degrees. Okay, so when we calculate this, right, it will give us a total of 1,307.5628. Okay, I just write more decimal places just in case. All right, so now find XC. Same thing, opposite over adjacent. So focus on the triangle AXC. So tangent 50 degrees equals to opposite, right? AX over XC or CX lah. Okay, or CX. Let me write CX. CX, okay, equals to 950 over CX, right? So CX is equals to 950 over tangent 50 degrees, right? Which will give me 797.1446. All right, so BC will just be equals to these two numbers add up, right? So when I add them up, it's going to be 2104.707, and then 3SF is just 2100 meters. Okay, so this is 3SF. Okay, so just take note for BC, right? There's a lot of ways to do it, honestly. You can actually do it in using sine rule or cosine rule. No, she's lying on my laptop. Yeah. Yeah, you can actually do it sine rule or cosine rule. So it's actually up to you. All right. Okay, can. So yeah, this is it for question 8. Okay, let's go through question 9 together. So there's a diagram here, so easier lah. So 4 houses A, B, C, D are at the same horizontal level, right? With B due north of A. So B is at the north of A. So that's why B is on top of A lah, as opposed, as you can see in the diagram lah. So this is something like a bird's eye view. Imagine we are all birds lah. So we are staring down onto the ground, right? And then we see this diagram. Okay, so this is how I want you to visualize. All right, and then B, C, D, B, C, and D are along a straight road. All right, so this is supposed to be a straight line. All right, so AB equals to 21 km, which is labeled here. And CD is 27 km, also labeled here. All right. Then the bearings of C from A and B are 64 degrees and 128 degrees, respectively. So it's all labeled on the diagram. So part A. All right. So how do we find the area of what you call that? The AC. All right. So we want to find this. Okay. So first thing first, we are going to do this. Okay. Actually, many ways to do it lah. Right, so first thing, I want to find out what is my angle ABC first. So part A, so angle ABC, right, is equals to 180 degrees minus 128 degrees. All right, this will give me 52 degrees. All right, so this is like adjacent angles on a straight line. Right, so adjacent angles on a straight line. Okay, 52 degrees. All right, then I want to find out what is my angle BCA as well. So angle BCA is equals to 180 degrees minus 52 degrees minus 64 degrees. All right, so this angle here, I also want to find out. So this is 180 minus 52 minus 64, so you'll give me 64 degrees. Ah, so then now we know, oh, this is isosceles because this is also 64 degrees. All right, but doesn't matter lah. It won't help us in finding AC for now. All right, so now next thing we are going to do this thing called sine rule lah. All right, so that means we can say that AC over sine ABC, right, which is 52 degrees, right, equals to AB, right, over sine 64 degrees. All right, because AB is 21, right, and it directly opposite is 64 degrees. So AB over sine 64. Or if you want to use BC over sine 64 here, also can. They are the same thing lah, actually. So AC over sine 52 degrees equals to AB, which is 21, over sine 64 degrees. So AC equals to 21 over sine 64 degrees times sine 52 degrees. So this will give us AC to be 18.41158. Round off 3SF, 18.4 kilometers. Okay, so this is 3SF, 18.4 kilometers. All right, so let's move on to part B. On the right, part B. So they want the distance AD. So AD, this one over here. Okay, so one look, I think we are going to do cosine rule. So we got to find angle ACD. All right, this angle here. And then we have AC found, right, in part A. And then we have 27. So this is a so-called condition for us to do cosine rule. Okay, so find angle ACD first lah. So angle ACD equals to 180 degrees minus 64 degrees, which will give us 116 degrees. So adjacent angles on a straight line. Okay, yep. So after that, yeah, we can actually do cosine rule already. So AD square, right, equals to 18.41158 square plus 27 square minus 2 times both of them, 18.41158, and then 27 cosine angle ACB, right? I mean ACD, sorry, which is 116 degrees. All right, so this will work out to be AD square equals to 1503.826. Okay, yeah, and then if I were to square root it, I'll get AD log. So AD is equals to 38.7792. Round off 3SF, 38.8 km. Okay, so this is 3SF lah. Okay, so this is my answer for part B. All right, then let's move on to part C in blue. So part C, the bearing of D from A. So from A, so that means they want this angle over here, which means we got to find out what is this angle here. Then we add 64. Okay, so actually we can do sine rule already lah. Because why? We got, you know, this angle over here is paired with 27, and we found AD in part B, right? And then we have this angle over here. So we can say, we can find actually. So sine angle CAD, right, over 27 equals to sine 116, right, degrees over AD, which is 38.7792. Okay, I hope you understand why I'm using sine rule here. All right, if not, I can actually explain also lah. So then we will work out that sine angle CAD is equals to 0. Sine 116 degrees over 38.7792 times 27. Right, this will be 0.625784. Yeah. Okay, so angle CAD, which is sine inverse the 0.625784, it will give us 38.73982 degrees. Okay, so lastly, because of the bearing, right, so we got to add with the 64. So 64 plus, bear with me because there's a limited space over here. So 64 plus 38.73982. All right, and then this will give us 102.7 degrees 1 dp. Okay, so the bearing of, so this part C, the bearing of D from A is 102.7 degrees, and this is 1 dp. Okay, so yeah, this is it for question. Okay, let's go through question 10 together. So 3 points A, B, and H are on level ground. So this is a question without diagram. So of course we got to draw lah. But the weird thing, okay, not weird lah, but anyway, for this side, there is actually two possible diagrams that you can draw because of the lack of specific information. Later we will explore those two diagrams. All right, so yes, A, B, and H are on level ground. A is 92 meter due east of H. So what it means is H, okay, so we're going to draw H first, all right, H over here. Okay, let me see if I can, yeah, H is over here, all right, and then A is due east of H, right? So that means it's like A is over here, okay, A is over here, and then this is 92 meters. All right, then they say HAB is 69 degrees, so this is 69 degrees, right, 69 degrees, and then AB, right, AB, so B is over here, B, all right, and then this is 65 meter. Okay, so there's another way of doing lah. What is the other way? Which is this lah. So same thing, H is over here, right, and then A is over here. So 92 meter, right? So instead of going up, right, B can actually be down, right, below A, below H and A lah. So it could be something like that. You know, it could be something like that. So B could be here, right? Yeah, so this is 92 meter, and then this is 65 meter. Okay, and then angle HAB is 69 degrees. Okay, it could be something like that. Yeah, so there are two possible ways how you can draw it. Okay, so part A, find the distance BH. So let's use another color. So part A, maybe I do on the left lah. So part A, find the distance BH. So they want this lah. Okay, so for both scenario, right, we will use the same method, right, which is cosine rule. All right, it doesn't affect, right, whether, you know, because in both scenario, right, the distance of BH, right, will not change. So we are going to use the cosine rule. So HB square, right, equals to 92 square plus 65 square minus 2 bracket 92 times 65 times cosine 69 degrees. All right, so HB square will be equals to 8402.9193, and then HB, right, square root, we will get 91.6674, round off 3SF, right, got 91.7 meters. Okay, so this is for part A. Okay, then let's move on to part B. So part B in black, the possible bearings of B from A. So we take a look at the one on the left lah. So bearings of B from A. So from A, right, draw a compass like that, north, and then they want this bearing. Okay, they want this angle. All right, so what do we do? Right, so in this case, because this H, I mean A is due east of H, right? So we know that this is 90 degrees. Okay, this is 90 degrees. So that means what we can do is we find out what is this angle over here. Then we take 90 degrees to minus this angle. Then we can get the bearing. All right, so how do we find out the angle here? We can do sine rule lah, right? So basically, sine angle, right, BHA over 65 equals to sine angle, or rather sine 69 degrees, right, over HB, which I found in part A, 91.67, sorry, 6674. All right, so sine angle BHA is equals to sine 69 over 91.6674 times 65, right? Which will be 0.661988. Then over here, so angle BHA will be equals to sine inverse lah, right? So 41.45167. So for this on the left, the diagram, right, the bearing will just be 90 degrees minus 41.45167, which will give us 48, right, 48.5483, round off 1 dp, 48.5, right, degrees. So this 1 dp. Later I'll write a final statement because bearings you have to write 3-digit, right? So I'll write a final statement later for both answers. Okay, so this is the answer for the diagram on the left. Right, what about the diagram on the right? So the bearings of B from H, right? So look, so same thing, I draw a compass here, B, right? So the angle is now this, So it's actually 90 degrees plus this angle over here. Yeah, okay, so it's actually 90 degrees plus this angle over here. So if you think about it, this angle over here, actually we found it in part A. I mean in, what you call that, the previous diagram. This is also, right, 48. I mean 41. BHA, right? 41.45167. Right? Because if you think about it, right, this angle and this pairing, right, we can use sine rule also. So angle BHA, right, over 65 is equals to sine 69 degrees over HB. Exactly the same as this part here, right? So this is actually 41.45167. So the answer for the bearings of B from H, right, for this diagram will just be 90 plus 41.45167, right? Which will give us a 131.5 degrees. So let me write a statement lah. So the two possible, right? Two possible bearings. Two possible bearings of B from H is equals to 048.5 degrees or 131.5 degrees. Okay, so this is for part B lah. All right, so let's discuss part C. So part C will be in blue lah. Okay, so part C over here, slightly no space, but I will just try my best lah. So shortest distance from A to BH, right? So let's use the diagram on the right lah. So shortest distance from A to BH. So they want this lah, right? They want this distance here. So remember, shortest distance means it will always form a 90 degree with HB. All right. So same thing lah. We can do this. We can use area of triangle to help us because we can actually find area of triangle in this case, right? So half AB sine C. So half times 92 times 65 sine 69 degrees. Okay, it is also equals to half times my base, which is HB, times the height, right, which is my shortest distance that I want to find in part C. All right, so if you figure out, and then, okay, we know HB, right? HB is found in part A, which is the 91.6674. So if you figure it out, right? So shorten the time. So half times 92 times 65 sine 69 is actually equals to, well, I didn't even do it. So basically, right, it's just the shortest distance is this thing over here, right? Divide by half, divide by HB, which is 91.6674. All right, so my shortest distance is equals to something like this. Let me just write it out. But you shouldn't write it in this way lah. I will calculate it. It's just that I have a lack of space over here. Okay, divide by half times 91.6674. All right, which will give me 60.9029 round off 3SF, so 60.9 meters. Okay, so 3SF. Yeah. All right, so yes, I'm using area of triangle for part C. Okay, because we learned two formulas for area of triangle, right? One in primary school, one like recently from Trigo. Primary school is half times base times height. Trigo is half AB sine C, right? So we can use half AB sine C to find the actual area. Then we use the actual area and impose it on half times base times height. So the height is the shortest distance, right, over here, which I labeled. And then the base is the HB, because the shorter distance, right, is going towards HB. And then HB is the natural perpendicular base lah. I mean, base that is perpendicular to the vertical height. Yeah, so HB is the base. And we have found HB in part A, which is 91.6674. So that's why we can use this property lah, right, to find the shortest distance from A to BH. Okay, so question, does it, because I'm using for diagram 2, right, does it work for diagram 1 as well? Yes, it does. It's the same thing actually. So if you look at diagram 1, half AB sine C, right, same thing. And then from shorter distance from A to BH is over here. So this will also form a 90 degree. Yeah, so half times base, which is HB, times the shortest distance, which is the height. So same idea, no matter which diagram you are using. All right, okay, so this is it for question 10.